Hi, this is Mrs. Baisden, and today we're going to talk about balancing redox reactions. So when you're balancing redox reactions, the first thing you have to figure out is whether it's an acidic solution or a basic solution. And for what we're doing now, the problem is going to tell you what kind of a solution you have. So we're going to start with how to balance the acidic solutions. When we move to the basic solutions, there's only one extra step you have to add. So for an acidic solution, your first step is to take your reaction and write the half reactions. So split it into the half reactions. Then you're going to balance the half reactions separately, and then you're going to add them back together and simplify to finish it up. So when you balance the half reactions, there's three things you're going to do. The first one is you're going to balance elements other than hydrogen and oxygen. So anything else that's not hydrogen or oxygen, you balance it the way we've always balanced it with the coefficients. Then you're going to balance oxygen atoms by adding water to whichever side needs it. Then you're going to balance the hydrogen atoms by adding H+. After you've done all that, then you're going to balance the charge. So you're going to look at the charge of each side to make sure that the charges are the same. Then you're going to multiply them so that electrons lost equals electrons gained. Then you're going to add them back together, cancel out anything that cancels, simplify it, and then you've balanced your reaction. This sounds extremely complicated just from looking at the steps, but once we go through a couple example problems, you'll see that it's really not that bad. Okay, so here's our first example. So we have our problem given. So you can see that the ion here stays with this one, and then you can see that those two stay together for the oxidation half reaction. It may or may not ask you to split them. It may not or may not ask you to label them as oxidation reduction. Most of them you can just split up and then move on from there. So we're going to look at the first one first. We're going to look at the first half reaction. So the first thing we're going to do is balance atoms other than oxygen. So if you look here, I have 2 chromiums here, and I only have 1 over here. So I'm going to put a coefficient in front of that chromium to balance those out. So that's my first step. That's balancing the mass of things other than hydrogen and oxygen. Then I'm going to balance my oxygens. So I have 7 oxygens on this side. I don't have any on the other. So I'm going to add 7 waters. Now I'm going to balance H's. So I have 7 times 2 is 14 H pluses. So I'm going to add 14 H pluses to this side. So now I've balanced the H's. So I've done all my balancing of mass. So I have 14 H's on both sides. I have 7 oxygens on both sides, and I have 2 chromiums on both sides. So that's my first step. The next step is going to be to balance the charge. So I'm going to look at the total charge on the left and the total charge on the right, and I'm going to add the electrons where they need to be here. So if I look, I have 14 times plus 1, so I have a plus 14, and then I have a minus 2 times 1, which is a minus 2. So on the left side, I have a plus 12 overall charge. On the right-hand side, I have 2 times plus 3, so that's a plus 6. And I have 7 times, this has a 0 charge overall, which is 0. So I have an overall charge of plus 6 on the right. So to balance that out, because the only thing I can add is electrons, to balance that out, the only thing I can do is add 6 electrons over on this side. So that 6 electrons with the plus 12 gives me the plus 6 that I have on both sides. Okay, so now I balanced the charge. So now I'm going to move on to my other one. So I'm going to go back to my other color here. So now I'm going to go down to my chlorines. So for the chlorine, there's 1 chlorine on this side, there's 2 chlorines on this side. So I'm going to add a 2 there. There's no hydrogen, there's no oxygen, so I don't have to worry about anything there. So now I'm going to balance the charges. So on this side, I have 2 times a minus 1 is a minus 2. And then over here, I have 1 that has a charge of 0, so that is going to be 0 on that side. So that means to balance those sides, I have to add 2 electrons on this side. Now the way this will work out is that you should always have the electrons on opposite sides. It's because one is losing electrons, one is gaining electrons, which that's reflected in where those electrons are. So for the reduction reaction, you can see the electrons are being added in, the oxidation, they're being given off or they're being lost. So then once I've done that, before I can add them back together, I have to make sure that the electrons cancel out. So right now I have 6 electrons in the reduction reaction. I only have 2 in the oxidation. So that means I have to multiply the reaction by some value so that the electrons cancel out. So that means this whole reaction is going to get multiplied by 3. So I have now 6 Cl minuses, and that gives me 3 Cl2 plus 6 electrons. Okay, so that's my overall for that one. Now what I'm going to do is add the 2 reactions together. This reaction right here, and then I have this reaction down here. So when I add those together, you can either cancel before or after, whatever makes more sense to you. I'm going to go ahead and cancel out the electrons because I can see that those are going to go. So I'm going to go ahead and get rid of those now. So that leaves me with 14H plus Cr2O7 minus 2 plus 6 Cl minus. Okay, so that was everything to the left, and that yields 2 Cr plus 3 plus 7 H2O plus 3 Cl2. So again, all that is that's this reaction up here added to this reaction right here. You cancel out anything that cancels on both sides, so that's why I got rid of the electrons. There should not be any electrons in your final equation, and then everything else should be simplified. This one you didn't have to simplify anything else, but then this at the bottom would be your final balanced redox equation. A basic solution. So basic balancing a redox reaction in basic solution, you can see that first set of steps is the same. The only difference is the 5th step. So we've added 1 step for basic solutions. If you have a basic solution, you're going to neutralize any remaining H pluses by adding OH minuses, which is going to make water. So again, we'll go through an example for this one. Okay, so here's an example of a basic solution. So I've already split this up into the reduction and oxidation. So I'm going to start up at the top. I'm going to balance things other than hydrogen and oxygen. So the MNs are both balanced, so I don't need to do anything there. Then I'm going to balance my oxygens by adding water. So I have 4 oxygens on the left, so that means I need to add 2 waters on the right. Now I have to balance my H's using H pluses. So I have 2 times 2 is 4 hydrogens, so I'm going to add 4 H pluses over here. So then I balance the mass, now I can balance the charge. So to balance the charge, I'm going to total over here. So I have plus 4 and a minus 1, so that means I have a total of plus 3 on the left. And then I have 0 and 0 over here, so I have 0 on the right. So that means I have to add 3 electrons to the left for that both sides to balance out to 0. Okay, so I've balanced the mass, balanced the charge, now I can move on to my other one. So then on the bottom, C and N are both balanced, so I have to add a water to balance out that oxygen. Then I have to add 2H plus to balance out the 2 H's. Okay, so I balanced the mass. Now I can balance the charge. So over on this side, I have a minus 1 and a 0, so minus 1 total. This one's a minus 1 and a plus 2, plus 1, 0. Sorry about the dog. Okay, so then I have now a plus 1 and a minus 1. So that means to balance that, I have to add 2 electrons over on this side. So 2 electrons plus 1 gives you a minus 1 on the other side. So now this one, I've got 2 different numbers of electrons. So I've got 3 electrons in the first reaction, 2 electrons in the bottom. So I have to multiply these all by something so that the electrons cancel out. So for this first one, I'm going to multiply this first equation by 2, and I'm going to multiply the bottom equation by 3. So 3 times 2 gives me 6 electrons plus 8 H plus 2 MnO4 minus. That gives me 2 MnO2 plus 4 H2O. So that's my equation from the top. Now from the bottom, 3 Cn minus plus 3H2O gives me 3CNO minus plus 6H plus plus 6 electrons. Okay, so now I'm going to add all these together. So I'm going to get rid of those because I know that's going to go no matter what. Then I could kind of look here and see if there's anything else I can cancel out before I add them together. So if I notice I've got 3 waters here, that will just leave me with 1 water over there. Then I have 6H plus that can go, and that's going to leave me with 2H plus up here. So I'm going to go ahead and add everything up here. So I have 2H plus 2MnO4 minus plus 3Cn minus. That gives me 2MnO2 plus H2O plus 3CnO minus. Okay, I think I got everything, so that's everything from up there. Now, because this is a basic solution, we said there's that one extra step. So the one extra step is any H pluses I have, I want to neutralize, and the way I'm going to neutralize those is by adding the same number of OH minuses. So I'm going to add, since I have 2 H pluses here, I'm going to add 2 OH minus, but I have to add them to both sides. So here's a 2 OH minus over here too. So what that's going to do is going to give this, the 2 OH minus and 2 H pluses are going to give me 2H2O, and I'm going to go ahead and rewrite this whole thing. 2MnO4 minus plus 3Cn minus gives me 2MnO2 plus H2O plus 3CNO minus plus 2OH minus. Now the last step here, the only thing we would have to do here, and I'm going to run out of room and not be able to write this, but I'm going to show you here on the bottom, is I can go back then and get rid of the one of these last waters. So this water here is going to go away, and that's going to change this one over here to just 1. So then that would be your final balance equation. H2O, 2MnO4 minus plus 3Cn minus yields 2MnO2 plus 3CNO minus plus 2OH minus. So again, basic solution, pretty much the same. You're just adding one last step at the end where you add however many H pluses you have in that final reaction after you've simplified. That's how many OH minuses you add, makes water, and then you go back and simplify the water.